Alright, there's a lot going on in this video. I'm going to show you how to find the zeros, the y-intercept, and we will talk about the symmetry of these equations because there's a couple more we're going to do off camera. The zeros are closely related to the x-intercept. And everyone knows if you want to find the x-intercept, you let y equal 0. All right, so basically you plug in 0 right there and you let her rip. Okay, I don't like having 0 on the left though, so I'm just going to imagine that it's over here on the right. All right, that's the same difference. So it's a matter of solving this. Factoring comes to mind for this particular problem. So I see there's a common factor of 2x everywhere. So I'm going to pull out the 2x. And then to imagine what goes inside, I'm going to divide everything by 2x. So that's going to leave x squared minus 7x plus 12. Now, we can factor some more. I see this trinomial here. I'm not afraid of you, trinomial. That's going to be a binomial times a binomial. Probably, heaven forbid, we have to use the quadratic formula. I'm sure that's not going to happen. X squared, I'm looking at you, that's going to be x times x. 12. 12 is interesting because 12 can be factored a variety of ways. 12 can either be, it could be 4 times 3, or it could be 2 times 6, or it could be 1 times 12. I need the middle to be -7. So I'm liking the 4 and the 3. So let's go with 4 times 3. Specifically, if I want to get -7, I'm going to need a -4 and a -3. Okay, because inner plus outer must equal the middle. And right now, inner, I have -4x. Outer, I have -3x. Together, that makes -7. That's exactly what I wanted. But also, -4 times -3 makes +12. So everything's working out great for me. I think I'm just going to erase this little work here that's kind of in my way now. Zero product property. If I set each one of these equal to 0, so if I'm doing 2x equals 0, x minus 4 equals 0, and x minus 3 equals 0, this each of these will give me the zeros of the function. So dividing both sides by 2, I get x equals 0. Adding 4 to both sides, I get x equals 4, so that's a 0. Adding 3 to both sides, I get x equals 3, so that's a 0. So these are the 3 zeros of the function. All right, now moving on to y-intercept. The y-intercept, you let x equal 0. See how this works? If you want the x-intercept, you let y equal 0. If you want the y-intercept, you let x equal 0. Which, by the way, means it's going to be 0, comma, something. So if I let x equal 0, that means I'm plugging in 0 here, and here, and here. Well, 0 times anything is 0, so all of these terms will be wiped out, and I'm going to wind up with 0 for the answer. All right, notice that an intercept is an ordered pair. So if I ask you for the y-intercept, I want 0, comma 0, or 0, comma 5, or 0, comma -2, whatever it is. Zeros are just numbers, not ordered pairs. Okay, now let's talk symmetry. A brief reminder of how symmetry works. There are 2 kinds of symmetry that we've learned about. There's even symmetry, and there is odd symmetry. Even and odd. Even symmetry means that you have symmetry around the y-axis. So here's a good example of even symmetry, would be like a parabola that is symmetric around the y-axis. That's even symmetry. Odd symmetry is a rotational symmetry based on the origin. So you'll know that you have odd symmetry if you rotate the picture upside down and it still looks the same. That's odd symmetry. Okay, now there's some other tricks I'm going to show you along the way, but graphically, that's what we are dealing with. Okay, now, so here's a shortcut that really only works for polynomials. The shortcut is, sorry, you can just look at the exponents. Boom, boom, and this is an invisible 1. If the exponents are all even, then it's going to be even symmetry. If the exponents are all odd, that's going to be odd symmetry. If you have a mixture, then that will be neither. And that's what's happening here. We have odd and even. We have a mixture of even and odd. So this is going to have no symmetry. All right, it's neither. It's neither even nor odd. So we'll just put none. All right, that only works for polynomials. So we'll have other techniques, like when we get to square root later, we'll have to sort of do it more graphically like this. Okay, but there's a lot of polynomials out there, so we'll get a lot of mileage out of that shortcut. So zeros, remember, for the zeros, we're going to let y equal 0. Okay, we're going to let y equal 0. That's how we get the zeros. In other words, you just set the entire function equal to 0 and you solve it. This can be factored, all right? This is the difference of two squares, so this will factor as x plus 1, x minus 1. So using the zero product property, I'm going to get -1 and +1. Look, another way you could have done this, if I add 1 to both sides, that's going to give me x squared equals 1. And then I could take the square root of both sides, but I have to remember to do plus or minus, so that'll give me x is equal to plus or minus 1. And that's the same thing as we got, so that's two different ways. Now, time for the y-intercept. For the y-intercept, we let x equal 0. And we see what happens. Okay, x is going to equal 0. Y-intercept will be an ordered pair. So if x is 0, that means it's going to be 0 comma something. Intercepts are ordered pairs. Zeros are just numbers. Keep it straight or you will lose points for that. Okay, if I let x equal 0, then that means I'm putting 0 right there. 0 minus 1 is just -1. So 0 comma -1 is the y-intercept. Again, if you just put -1, you're going to lose points. All right? Intercepts are ordered pairs. Don't just put -1. It's got to be 0 comma -1. Symmetry. We can use our shortcut where we talk about the exponents. But one minor little twist here. We need an x on every single term. Every term has to have an x so we can talk about the exponents. So I see x right here, but what about this? The reason why we didn't write this x down is because this is the same as x to the 0 power. So when I ask myself whether or not the exponents are even or odd, I'm looking at exponents of 2 and 0. By the way, fun fact, 0 is an even number. All right, some people do not know that. So 0 is an even number. Obviously 2 is an even number. All of the exponents are even. So this is going to have even symmetry. Even symmetry. Okay, we could have easily done this graphically as well. See the x squared? That tells us that the parent function is this. Okay, we're talking about x squared. So the parent function is like shmeh. Man, okay, that's just a little ugly, sorry. I'll just make it a little tighter. Anyway, so the parent function is a parabola at 0, 0. But then you throw this -1 on there, and all that does is it moves the parabola down 1. Okay, so instead, now it's going to be down here. All right, but we just moved it down 1. That is all. So this will still be symmetric around the y-axis. It's still going to be even symmetry like we explained before. So that's another way that you could think about it. All right, let's do problem number 13. The zeros, we will let y equal 0 and solve. In other words, we're going to set the whole thing equal to 0. That's how you find the zeros. Well, probably the easiest thing to do is add 3 to both sides. So I have the square root of x is equal to 3. How do I get rid of this radical? I'm going to square both sides. So that's going to give me x equals 9. So I only have one 0, and it is 9. Time for the y-intercept. For the y-intercept, you let x equal 0. All right, if you let x equal 0, that means I'm putting a 0 right here. 0 minus 3, that's going to be -3. I let x equal 0, so I'm going to have 0 comma -3. A y-intercept is an ordered pair. If you just put -3, you're going to lose points. You have to put 0 comma -3. All right, now it's time for symmetry. This is not a polynomial, so I can't use my trick of just look at the exponents. If they're all even, it's even. If they're all odd, it's odd. I can't do that. This is not a polynomial. So I'm going to use what I know about the graph. And I see the parent function is the square root of x. And we know that the square root of x, the parent function, looks like this. It's half of a sideways parabola. So all that has happened, the only transformation is this -3. That just takes the entire graph and it moves it down 3. Okay, so it's going to be down like this instead. All right, so here we are at -3. But symmetry. Is this symmetric around the y-axis? No, it's only going to one side. Will this have rotational symmetry? Does it look exactly the same if I turn it upside down? No. If I turned it upside down, it would be like over here in a whole different quadrant. So I can tell graphically that this has neither symmetry, so I'm just going to put none. All right, moving on to the last one. All right, for the zeros, we let y equal 0. In other words, we set the whole thing equal to 0. I could divide both sides by 4, and that will give me x to the third power is equal to 0. If I want to get rid of the third power, I would take the cube root of both sides. So that'll give me x equals 0. So that is the 0 of the function, and the 0 is just a number, so I'll just put 0. For the y-intercept, I let x equal 0. And see what happens. Okay, so if I let x equal 0, I'm putting a 0 right here. The y-intercept is an ordered pair, so it's going to be a 0 comma something. If I plug in 0, I'm just going to get 0. So the y-intercept is 0 comma 0. If you just put 0, you're losing points. The y-intercept is an ordered pair. You must put 0 comma 0. Now, symmetry. This is a polynomial, so we can use the exponent shortcut. So there's only one exponent, boom, x to the third power. So because that is odd, then we know that this will have odd symmetry. All of the exponents are odd. The only one exponent is odd. And that is it. That is how you find zeros and y-intercepts and symmetry for a variety of functions.